Okay, let's unpack this. What if the very tools designed to give millions, a better education actually end up making us, well, less capable?
Mm,
That's the big question we're diving into today. We're
yeah.
moving past the usual debates about cheating or lazy students
Mhm.
when it comes to AI tutors in higher education. This feels like something far more fundamental.
Absolutely. What's fascinating here, I think, is that we're exploring a core mismatch. It's how these powerful AI systems are designed to operate versus how our current educational structures actually measure success. Our goal today is to really dig into why we're seeing these growing concerns about critical thinking decline and, maybe more importantly, to uncover a viable path forward.
Right.
A path that doesn't mean sacrificing access to these incredible tools. We're going to reveal a deeper, often invisible problem, what we're calling cognitive drift.
And the material you've provided for this deep dive, it offers a truly innovative framework around this idea, this difference between drift and atrophy.
Hmm.
It even proposes a pretty radical new solution, drawing on insights from, well, programming, data science, even cognitive neuroscience. It's a real cross-disciplinary look at a pressing issue,
Uh-huh.
focusing especially on one cutting-edge approach. So let's start with a position that feels, well, almost impossible to argue against.
Okay.
For centuries, right, one-on-one personalized instruction was pretty much exclusively for the aristocracy, for the incredibly wealthy. Imagine having a dedicated tutor just for you whenever you needed them.
The ultimate luxury.
Exactly, the ultimate luxury. But now AI can democratize that. A student in, say, rural Kansas could potentially have the same quality of personalized instruction as someone at Harvard, available 24/7. How can anyone rationally argue against something that sounds so compelling? So,
You're absolutely right. It really is an indefensible position, as the source material puts it, to simply oppose AI tutors on principle. Doing that is basically saying only the elite deserve personalized education. But here's the rub. Our traditional educational structures, things like standardized tests or this rigid semester-based feedback loop, they're just not built for this new reality.
they're too slow.
Way too slow. They're designed for a pre-AI world. And this creates an impossible choice for universities. Either they restrict access to these powerful tools, which is, frankly, politically difficult,
Yeah.
or they embrace AI democratization and, often without realizing it, accept the invisible cognitive drift that can come with it. It's not about anyone being malicious, it's a profound measurement crisis.
That measurement crisis you mentioned, that really seems to nail the problem. But okay, where do we find a model for quicker, more effective feedback? Maybe we can look at a field that absolutely relies on it.
Right.
Programming.
Yeah.
What's their debug moment all about?
It's this fundamental truth programmers live by. Suffering equals the absolute difference between intent and result. Sounds dramatic, but
Huh, yeah.
when their code doesn't do what they intended, they suffer. They waste time, energy, debugging. But the crucial point is, they can see this drift, this gap between their intention and the actual output almost immediately.
Instantly.
Pretty much. Their drift detection toolkit is huge. They have compilers, these super fast checks unit tests for small bits, peer code reviews, real-time monitoring. They have a constant real-time feedback loop.
Okay, now compare that to a university. What's their drift detection toolkit? You've got midterms, right? That's often month-delayed feedback.
If you're lucky.
Finals, semester delayed, graduation rates, years down the line.
Yeah.
Employment outcomes, that's career delayed feedback.
And alumni feedback can be generational.
Exactly. So this speed mismatch, where cognitive drift is potentially created at millisecond speed by AI, but it's detected at semester speed, or slower, by universities, that's what's really breaking higher education, isn't it?
It really is. And, many critics worry about cognitive offloading, and sometimes they miss this deeper point.
Because every tool offloads work, right? A hammer offloads the physical work of hitting a nail.
Writing offloads memory.
Exactly. The issue isn't the offloading itself.
No, it's when that offloading creates invisible drift. That's right. This cognitive offloading is quite a paradox. While every tool lightens our load in some way, the research in your sources shows that AI offloading specifically correlates with reduced critical thinking. In fact, some studies show a really strong negative correlation, like an R value of negative 0.75, which means, basically, increased AI use strongly links to decreased critical thinking scores.
Wow, that's significant.
It is. The real problem isn't augmenting our capability, AI helping us do more, but when that augmentation inadvertently replaces capability entirely.
And this leads us to a really crucial distinction, something that's so important for you, the listener, to get your head around. The difference between drift and atrophy. Okay, so think of it like this. When you drift, You and the AI are kind of evolving together, maybe in ways you didn't intend. But the good news is it's still potentially detectable, maybe through pattern analysis.
If you have the tools.
Right, if you have the right visibility tools, it's correctable, and you maintain agency. So an example might be using AI to help write essays. Over time, you start to notice your unique voice. Your style is kind of fading. You could still write without it, but it's just not quite you anymore. That's drift. Now, atrophy. That's far more terrifying.
Much more.
This is when you outsource a capability entirely to the AI. It becomes invisible until there's a crisis moment. And by then, it's often irreversible. You effectively lose the ability to even set the intent for that task yourself.
You can't even start it.
Exactly. The example here is finding yourself literally unable to write any essay without AI prompting you, like word by word.
Yeah.
Because you've completely outsourced the skill. And this brings us to this really compelling story from the sources. Maria, a pre-med student.
Ah, yes, the Maria example.
Brilliant student, apparently. Acing her organic chemistry problem sets using an AI tutor. She optimized for speed, correct answers, the metrics.
With the system measured.
Precisely. The drift was invisible, but the atrophy became catastrophically clear during her oral final. Her professor asked her to solve a novel problem on the whiteboard, a problem she hadn't seen before. She froze completely. She hadn't just outsourced the work, she had outsourced the entire cognitive process of breaking down a problem from first principles.
Wow.
This is the terrifying part. Drift often leads to atrophy, and by the time you notice the atrophy, it's often way too late.
Maria's story is such a powerful illustration, and it highlights a critical failure point we've actually seen in other real-world AI systems where the intent diverged from the result. Consider Amazon's AI hiring tool. Remember that?
Oh, yeah, that was a mess.
It was eventually scrapped because it showed significant bias against women. Now, the AI wasn't explicitly programmed to be sexist. It was designed to find the best candidates based on historical hiring data.
But the data was biased.
Exactly. The intent find top talent drifted dramatically from the result, which was just replicating past hiring patterns that favored men. Or think about, educational chatbots that confidently give wrong answers. There was that Stanford study that found ChatGPT confidently provided incorrect medical advice 30% of the time.
30%. That's huge in medicine.
It's massive. So if these big commercial AIs can't consistently navigate basic fairness or accuracy, what happens when educational AIs try to balance efficient learning with something much harder to measure, like deep understanding?
Yeah, this points straight to what the research calls the meta-learning problem. The AI tutors, they tend to optimize for what's easily measurable, right? Correct answers, how fast you finish.
The easy stuff to track.
But they often don't optimize, maybe can't optimize yet, for what truly matters.
Yeah.
Deep understanding, critical thinking, creativity, even intellectual courage.
Right.
And this optimization drift is totally invisible until students have that Maria moment, until they realize they've become incredibly efficient at not thinking for themselves. So what does this all mean for a solution? If the problem is invisibility,
then the solution has to be visibility.
Exactly. The core idea proposed in your sources is to make this cognitive drift visible. Imagine if students could actually see their cognitive coverage in real time, like programmers see code coverage, but for thinking, a cognitive heat map.
And this is where one particularly fascinating framework explored in your sources, the FIM v6 patent, comes in. It proposes a really radical way to do this through several breakthroughs.
Yeah, break it down for us.
All right. First, it uses something called orthogonal decomposition. So instead of trying to measure fuzzy concepts like creativity as just one big thing,
Which is impossible.
pretty much, it breaks them down into distinct, trackable components that are statistically independent. So think of creativity not as one score, but maybe as novelty multiplied by relevance multiplied by execution. Or critical thinking broken down into analysis times synthesis times evaluation. This makes abstract skills measurable.
Interesting. Okay, what else?
Second, it implements a principle called position meaning. This means the physical location of data within the SEM system inherently encodes its semantic meaning. It makes finding connections incredibly intuitive and computationally fast.
Position equals meaning. Got it.
Third, it introduces aware blind spots. So instead of just hiding information that hasn't been explored or isn't immediately relevant,
Which most systems do.
right, this system explicitly represents those unexplored regions. It even attaches metadata explaining why they haven't been explored. This lets experts selectively dive into those areas almost instantly. That's what O1 exploration means. It's basically instantaneous access no matter how much data there is.
Wow, and the performance.
The performance metrics mentioned are pretty staggering. The sources cite a 361 times speed up for medical diagnosis queries, 3,750 times for supply chain optimization, and less than 5 milliseconds latency for brain-computer interfaces.
Okay, sub 5 milliseconds. That's real time. So what does this vision actually look like in practice? For students, say. Imagine for students, getting real-time cognitive heat maps, maybe instant drift alerts popping up like, warning, your synthesis capability is cooling down.
Or corrective nudges like, hey, try this problem without AI first.
Yeah, and maybe agency dashboards showing your intent setting strength.
Yeah.
For educators, this could mean seeing class-wide drift patterns, early warning systems for students who might be falling behind invisibly.
And making data-driven curriculum adjustments, not just based on test scores.
Exactly. And then for universities themselves, it's a fundamental shift, right? From just looking at lagging outcome metrics to having clear process visibility. They could actually invest in drift detection infrastructure, maybe create, I don't know, cognitive gyms for capability maintenance.
That's a great way to put it. And of course, this immediately brings up questions about privacy and equity, which are crucial.
Definitely.
The material emphasizes privacy by design. So using anonymized data, ensuring students own and control their cognitive heat maps. For equity, the vision includes things like open source components, tiered pricing models, maybe mobile-first design to make sure it's accessible broadly. And it's not just for higher ed. Think about K-12. This could mean using supervised heat maps to really build those foundational skills from the ground up, and importantly, actively addressing the digital divides that already exist. We need to make sure AI benefits all students.
Right. Absolutely critical. Okay. So if this FIM framework or something like it is so potentially powerful, what does it mean for all the current solutions people are trying? You know, the critical thinking workshops, AI detection software, even just policies about balanced AI use.
Yeah, the research you shared argues pretty strongly that many of those are essentially band-aids.
Treating symptoms.
Exactly. They treat symptoms or their static solutions trying to fix a dynamic, constantly evolving problem. It's like teaching someone specific swimming strokes while the pool itself is slowly draining away. By the time you notice the water's gone, you're just practicing strokes on dry concrete. It doesn't help. Precisely. And the material doesn't position this FIM idea as some kind of proprietary silver bullet or monopoly.
Okay.
Rather, it frames it as potentially the first robust implementation of a universal principle, kind of like how the Black Scholes model provided a definitive way to price financial options back in the day. This technology, or ones like it, aim to define what proper cognitive drift detection actually means. It's about establishing the fundamental principle that cognitive drift must be made as visible, as measurable as academic performance itself.
And what's really fascinating here, reading through it, is that effective drift prevention isn't just about one magical tool, is it? It really requires an entire ecosystem of solutions.
That's absolutely key.
So things like AI literacy training,
Yeah.
designing hybrid assignments that cleverly blend AI and human work, fostering peer learning networks, encouraging reflective practices. FIM doesn't replace those.
No, not at all. It enables them. By making the drift visible, FIM allows all these other strategies to actually work better, to be targeted more effectively. It provides the map, so to speak, so you know where to apply those other interventions.
It gives you the where and why.
Exactly. And there's this really profound concept mentioned called the second-order acceleration effect.
Uh-huh.
The idea is when you can break things down into truly independent categories, like how skills are decomposed orthogonally in FIM, then even relatively less intelligent processes, simple algorithms, can accelerate dramatically toward achieving human-defined goals.
So it's not about the algorithms being super smart.
Not necessarily. It's about structural intelligence.
Huh.
FIM, in this view, functions as an intention engine. It amplifies the human-defined goals, the platonic ideals, if you will, or just, what we want students to learn through this property of statistical independence. And by doing that, it actively counters the drift away from those intentions. They've even seen precisely. The technology exists, or at least the foundational principles do. The math works. The choice before us is actually pretty simple, conceptually at least. Do we make cognitive drift visible at the speed it occurs? Or do we accept the atrophy that inevitably follows invisibility? Because right now our educational feedback loops are just fundamentally mismatched to AI's pace of change. It really is like trying to track a Formula One car using a sundial.
Yeah.
It's time to synchronize our clocks.
A powerful image. So as you reflect on this deep dive, maybe consider your own cognitive landscape. First, maybe audit your own drift. What tasks can you no longer do as easily or maybe at all without AI? Where has efficiency for you maybe replaced true understanding? When did a helpful tool start feeling more like a crutch?
Good questions.
Second, demand visibility. Ask your professors, your institutions, about drift detection in courses using AI. Maybe even request cognitive heat maps for your AI-assisted work. Push for that real-time feedback, not just the semester-end surprises. And finally, maybe practice some intentional friction. Just small things. Solve one problem today without reaching for AI. Write one paragraph by hand. Debug an issue just through reasoning, not immediately searching online.
Rebuilding those mental muscles.
Exactly. Your cognitive map exists. The question is, can you see it?